So today we are going to talk about something which looks complex at first, which is distributions. But once you see the pattern, it becomes surprisingly intuitive. Most beginners think distributions are just statistics diagrams, a weird looking graph in a textbook. But in real projects, distributions are actually the shape of reality. And this changes everything because data is never just values. It has behavior, patterns, and personality. Some things cluster normally, some are heavily skewed, some have multiple behaviors hiding inside them. And if you miss this, your entire analysis can go wrong. So let's make this real. Imagine so I'll give you example of salary data, which is our favorite, right? Then delivery times because we order online, at a great frequency. We can take this data, or maybe customer spendings, your own spendings. Uh, for me, I can take YouTube video views. So these are all our data types. So tell me one thing. What do you think? Do this behave in the same way? No, the answer is not even close. Some are balanced, some are extremely skewed, some secretly contain multiple groups of people. And most beginners don't notice this at first. They only look at averages. But remember one thing, averages can lie. Let me simplify this. Imagine you're standing outside a college exam hall and your task is to record the students' mark. You ask students their marks. Most students score around the middle. Very few score extremely low or extremely high. This creates a familiar pattern, which is hill-shaped pattern. And which is that distribution? Normal distribution. See this. Understood? Now I'll give you a second example. YouTube subscribers. So for example, my channel, it is new channel and it has a specific niche. So my channel has very few subscribers. But some channels are very popular. They have million subscribers. What kind of distribution it will show? It will show skewed distribution. Okay. Now I'll give you one more example. Imagine I have mixed data of height data of adults and children. Okay. Now if you'll plot this data, what you'll see? Two peaks. Okay. And that is bimodal distribution. So let me simplify this. Normal distribution is our famous bell curve. Most values cluster around the center. Examples of this are human height, IQ scores, manufacturing measurement. Okay. Now tell me, why does this happen? What do you think? You can write in comment later. I'll give you answer now any which ways. Because many tiny factors combine together, and in real systems, remember, and in real systems, small random effects often average out. That's why we see this. Now I'll give you one insight. The normal distribution appears so often because reality itself is built from many small random influences. I'll repeat it and you have to remember it always. The normal distribution appears so often because reality itself is built from many small random influences. Now I'll explain the second, that is skewed distribution. This is where real business gets interesting. In real companies, you will always see revenue is skewed, user activity is skewed, website traffic is skewed. So small number of users create most activity. Remember this as our 80-20 famous rule also, so in that also they say that the 20% of the outcomes come from the 80% of the activity which you do, and 80% of the outcome comes from that focused 20% of the activity. Same like maybe in organization, 20% of that top uh, uh, performing employees generate 80% of revenue for the organization. What is this? Skewed distribution. Remember, okay? And this is why companies obsess over power users, high value customers, you know, the employees which are high performing employees, viral creators, because distributions reveals where value actually lives. Production level thinking. So in real project, this is where things get tricky. Many machine learning models quietly assume data is somewhat normal, but business data often is not normal. And if you blindly apply models, you get misleading conclusions. I have told you a very interesting and important insight just now, and I hope you'll remember, because it often happens in the real world examples. When we apply the models, we don't even understand as beginners, or maybe sometimes as a mid-level professionals, that the models are assuming the data is normal. It is a normally distributed data, but in real world the data is skewed data. And if we apply this model blindly, the results are misleading conclusions. And this is where the experienced data scientist comes into the picture. And how it works: experienced data scientists inspect distributions before modeling. So, as a pro tip, you have to always inspect your distributions before modeling. Okay, now let's go to bimodal distribution. This one is fascinating. A bimodal distribution often means you are accidentally mixing different populations. Remember, what does it mean? You are accidentally mixing different population. Example, if I am using average app usage across teenagers, senior citizens, I'm not taking that cohorts. I'm just taking all the data. So I'll see very different behaviors. Two peaks may emerge, and this is a huge business insight, because suddenly if this kind of data is there, you will understand your population is mixed. So you have to create different cohorts and then see the behavior of that data. Okay, so this one strategy can help you a lot. And taking all the data and applying distributions or seeing the graphs, this strategy cannot serve everyone. So let me simplify this. Histograms. Histograms are not charts, they are stories. Now I am coming to histograms. Histograms are not charts, they are stories. What does histogram tell you? Where people cluster, where unusual behavior exists, and where groups are hidden, where they are hidden, and where risk exists. So, experienced analysts or data scientists, they do not just plot histograms. They read the behavior of it, reading histogram like a pro. So, when you see a histogram, you have to ask, where is the center? You will ask, what is typical? That means how spread out is it? You'll ask its behavior. Is it stable or chaotic? Is it skewed? And you'll also see the peaks. Are few extreme values dominating? Does it have multiple peaks? Are there any hidden groups? So if it has multiple peaks, I have told you it has mixed population. So you'll understand. Are there any hidden groups? So histogram is basically an X-ray of how reality behaves. I'll give you a real world example. Let's take finance examples. So income distributions are heavily skewed. Always. Income distributions are heavily skewed. Then if we will see healthcare domain, what is skewed? Patient recovery time, it varies widely. We will take e-commerce domain. Tiny percent of product. I told you 80-20 rule, Pareto chart rule. A tiny percent of products generate most revenue. If I will give you social media, a few creates dominate engagement. So this is what is very important to look in your charts, to understand in your charts. Okay. So I'll tell you the common mistakes which beginners make. They only calculate average. They ignore simply the distribution shape. They assume all data is normal and they miss hidden populations. Okay. And this creates dangerous conclusions. So I'll give you key takeaway. We are going to end our this particular chapter, and I want you to remember this takeaway before I conclude. Before I conclude this, so before modeling data, you have to understand its shape, because the shape often tells the real story. I will repeat it one more time because this is the takeaway which I want you to take before leaving. And if you have watched this video till end, I want you to remember this key takeaway and apply it in your future projects. What is it? Before modeling any data, you have to understand what is the data shape, what is the shape of that data, and then you have to understand what is the real story, because the shape is going to tell you the real story of the data. Okay, thank you very much. I will come with the next topic very soon. Thank you. See you.